Okay. Hello, folks. I am exhausted. I just got myself in a very hard 5K and a bunch of lifting, and I'm tapped for the week. Can't be tapped for the week. I gotta stream all day tomorrow. Gotta work on some stuff. So here's what we're gonna do today. I'm not gonna try to mess with anything super fancy. I'm just going to play around with our sweeps. I'm gonna see if I can figure out a couple quirks that we have with them. And we're going to go from there. We're going to see what happens, yeah? So there's no point in us keeping on this run, because it's not sweeping everything the way that we want it to anyways. It is doing decently, though. And what I'm specifically hoping is that this run here gives us some quite usable parameters. I believe it should. I believe that it should. So yeah, this is not sweeping the network at all. It should be sweeping the net params. So I would believe that this is about as good as we can do without touching the net params. Oh. Wait. Huh? I don't understand this. Why? Wait. Why are our parameters not here? Did I mess up sweep somehow? I mean, this looks like very bad. Huh. Yeah, this looks very, very bad. So apparently I just ran like several hundred experiments without sweeping anything. I don't know how that would be possible. That's a sweep. What on earth did I do? I mean, that's quite a spread then. I guess we just have like unstable hypers. Because we had some runs get to 5K score on this. At least this is a good reason for it to have not like done ridiculously well. So let's see. Fold. Sweep.suggest. Arcs. Right? I think I know what happened. You imbecile. You utter imbecile. Okay. Well, that was completely dumb. Well, I want to check that this is correct now. Unfortunately, I don't want to like do a full sweep. That was a really dumb error. That's a really dumb way to lose some experiment data. It's kind of crazy though that there was that much variance in like look how much variance there was, right? So this one here is like close to 5K score. So if these are all the same hypers, right? And this is actually filtered. If I take this off and I just like, yeah, 50 runs, it's quite a bit of variance, right? Like some of these are only down at 2K, some of them are all the way up at 4.8. Oh, and look, we have the distribution right here. Ignore these ones. These are probably manual runs. Okay, it's not that bad though. Like, they're not just failing. Yeah, so we can see here now that this is actually sweeping correctly because it's exploring different size networks and such. Interesting. I do actually kind of wonder though, because if you increase the network size, I do wonder if there's going to be this thing where like smaller nets train quicker. We probably have to mess with that. There's honestly probably like a lot that we need to still do on this sweep space. Because now we're sweeping net architecture basically as well. So this is no longer just hypers. But we've done enough innovation for one update, I'd say. Well, that's a little disheartening. What are we going to do now? Because there kind of go my plans for the afternoon. See if we have a reply here, and then we'll come up with something to do. Cool. I guess one thing we should do, let's sort of quantify. We'll let this do a few experiments. In the meantime, quantifying complexity. How much jank is there? Sweeps. I think there are only like a couple hundred lines realistically. Retail sweep silly PufferLib. I just want to quantify like how much crap I think there is still in each of these. So what we have 1,300 lines here. Let's just kind of look at the code. Train is fast. We're short. Dashboard. Compute puff advantage binding. The profiling needs to be, and the utilization perhaps. That's fine. Profiling, utilization. Okay. I'm just kind of going through and trying to figure out like how much better do I think I can make everything. I mean like how much shorter can I make everything? Okay, they're like some small chunks of reused logic, I suppose. It's actually not that bad, though, I would say. Yeah. It's not actually as bad as I think. It's like not super redundant. It's mostly just messy. Jeez, 1,800 lines of modules garbage. Okay, let's figure this out. So log coefs and values, this doesn't get used, right? Yeah, I don't think this gets used. RMS norm, fuse scan, scan checkpointed. Fuse PPO loss, massive. Holy crap. Hang on 1 second. Okay. Oh yeah, this is the optimized one. Okay, so I think like 2/3 of this file just gets deleted. We can even do that today. That's super easy. And then some of these functions that live here are a little questionable. The nice thing is a lot of this is hand editable. Life without TikTok and instead been so good, thanks. I'm telling you, man, it's poison. I think the thing that I'm guilty of most is when I get like playing a game, I'll go watch a whole bunch of YouTube about the game. At the very least, though, it's long form content. It's not short form, which feels substantially better. But it would still be way better if, in between doing other stuff, I just listen to my audiobook instead of watching garbage. I think audiobooks are basically the only form of entertainment where I can just like enjoy it, relax, and then not keep thinking about it in the background throughout the rest of my day. Feel like I could actually focus. Yeah, it's the most ADHD inducing stuff ever. It's like manufactured ADHD. It's awful. Like this stuff should just not exist. Able to set up the phone? No. I was lazy. There's some cool stuff done though. I'm kind of just going through right now. I'm going through all the code that I have and just like assessing redundancy, right? I'm just like figuring out here. Because like if I do this, right? Like we have 300 lines here, 1,000 lines, 1,800 lines, 4,400 lines of C++, not including our test files. So what of this do we actually need, et cetera, et cetera? How's your sleep like? Sucked last night because I stayed up late being stupid and then the dog woke me up this morning. Um, but you should aim to get like 8+ hours, ideally more. Like if you're also keeping in good shape and you're not blessed with amazing genetics, you can very easily need more than 8 hours. Sleep is very important. As someone who spent like many of my formative years not sleeping at all, sleep deprivation is pretty much indistinguishable from depression. It feels awful. Like, do not compromise your sleep. Yeah, don't stay up watching that. If you need something to fall asleep, I highly recommend an Audible subscription. You don't have to be looking at your phone. You can just listen to a book until you get tired and then just turn it off and go to sleep immediately. It's great. That's actually the one thing that when I do that consistently, it's noticeably better the next day. I revise mostly context, I forget stuff the next day. Isn't my man? I honestly, I don't know if you're in undergrad or if you're in high school or grad school or what. Um, in my younger years, it was awful. I basically was so constantly exhausted and sleep deprived that I would have to study for 3 times as long to retain anything, and then it would just be a vicious light cycle where I'd be working over 100 hours a week and not sleeping, and trying to also have to play sports. Um, you retain information better fresh, well rested. There is a maximum amount of information that you can retain effectively. There is essentially no way around when people just pile too much work on you. There's essentially no way around doing work ineffectively, and you just have to grind hours. You can optimize other stuff with sleep and try to like get better sleep. You can try to be fresh, you can try to cut out other stuff, but at some point if there's too much work, it's just you're kind of fucked. High school finishing next year. I will say, I guess I don't know your situation. I will say that's like the probably the hardest and worst chunk of my life was like the last year or so of high school, year or two of high school. It does get better. I don't really have any advice for you other than just like completely grind that so you're good for university. I don't know if you're in the US. In the US, it's basically you just work your ass off, and there's no way around it. In Europe, it's much easier, right? I don't know where in Europe. Is it just like your placement to university gets decided based on a test? Hey, SD. Because if it is and you're already like able to do that, um, if it is just on that and you are already able to do that, that gives you more bandwidth to learn other stuff. Yes, it determines if you're already able to like if you're already positive that you're going to be able to nail that to go, to the best place that you could realistically be able to, um, then you should end up having spare time to learn other stuff. Because I can tell you that, like, just knowing what you're taught in high school, by the time you get in college, you're at a very, very severe disadvantage because all these opportunities open up to you, but you are not qualified to know which of them are actually interesting or viable because you don't have any deep experience in any of these fields. And intro classes are a very, very bad way to judge like what fields you're interested in, and what types of problems you'd like to work on. Stopped using Claude Code. I still use it a little bit. I'd like to have it more out of my workflow. It's very, very stupid. It is useful in, I think it's mostly useful in situations where you have relatively deterministic operations, like a very well-defined refactor op or whatever. You are stuck with a big, messy code base that's pretty much takes forever to edit manually, and you can't do anything about it. Most of the time you should work very hard to put yourself into a position where you don't have to rely on Claude Code. Like your code should be short and succinct and human friendly. Sometimes that's not going to be possible because you're working with third-party crap that's just awful, which is what I've been doing with Torch. But I would like to have that be less so the case because this is frankly just not enjoyable in any way. You learn way less with like relying heavily on the AI tools. You will write worse code. You will hand off too much of your thinking to the AI models, and the people that build them hate you. So, yeah. I will still write the blog at some point. I've been busy like building actual stuff though. You still review code? Yes, I do still review code. I get backlogged quite a bit. It depends how long of a review you need, though, right? Like really big NPRs that are gonna take me 3 or 4 hours to review, I have to like set aside a good day to do that. It also has to be at least reasonable code for that. For newer contributors that write like a 400 or 500 line env, that I can review pretty quickly, like whenever on stream. I will be mad though if it's all AI generated crap. Which autocomplete? Um, this is Super Maven. It's no longer available, unfortunately. Cursor bought it and killed it, and then all the Super Maven users bitched so much that they said, fine, we'll keep serving it to existing users. Okay. Let's make a quick commit before I start messing with stuff. Grades are just decreasing. I don't know what that is. That means. Yeah, the one thing SFing you absolutely do not want to bungle is university or undergrad. You do not want to bungle admissions. You're basically fucked if you do. Mm. Hey Jess, what are you working on? Cleaning up PufferLib. We have some sweeps running. And I just wrote this. I kind of went through and I kind of like saw where all of the bad code is. We're gonna go through and delete all the stuff that's easy to delete first. And then we're going to start actual refactors. Hello, welcome. Not needed. Utilization, we'll leave that for now. I think this is the only thing I can, get rid of this as well. Have you tried Z? Sweep AI autocomplete. No, not really. I wouldn't mind a local model, honestly. I don't want a good, I don't want a super strong model. I just want a fast model. Like, I want something that has 100 ms completion time, ideally less. Single line only. The hell is this? Oh, I know what this is from. That's fine. I really don't need that much stuff. We actually are no longer going to need autotune, funny enough, because the function of autotune is now handled by sweeps completely, which is pretty cool. Like, sweeps fully does what autotune used to do. Okay, minus some lines, yeah? Couple hundred lines. This one's harder to edit, I think. Let's get rid of modules that are bad. This is the easiest thing to just delete things. We don't use log coefs and values, do we? This entire thing is fused. Oh, I didn't check kernels.cu as well. Duh. Let's just delete the dead code. Self-play to take advantage of sweeps. Your code. The code is simple. This is not simple code here. This is a mess, SFing. This is a complete disaster. If you want simple code, like, here. This is our snake implementation. Like, read this if you want, like, an example of how to make a useful env in a couple hundred lines of dead simple code. This is nice. I got to write some C environment stuff for a client yesterday, And it was so much nicer and easier than this crap. Like this is basically me making the best of the worst library ever, which is the Torch backend. And this is going to get a lot simpler as well. We have, first of all, just like a lot of dead code that we don't need to deal with. This log cum sum x, I think we should keep this. We don't use this directly at the moment, but it is a useful test point, I think. PPO fused loss we can delete because we have the optimized one. All this garbage just gets to be deleted. My CS teacher made coding hard. Yeah, they do that though, SFing. They really do that. I was taught Java. It literally took me years to unlearn Java. Like, I don't know what type of addled mind produced that crap, but it's awful. Logits. This one is bad. This one is just not good. Some form of hard-coded opponent. If you can get one, it would be nice. Down to what, 970 lines? That's a whole bunch of crap deleted, right? And delete the RMS norm and die T. Do you want to delete RMS norm? Some part of me is like, hey, it's really hard to get good perf without the RMS norm. But I just know that we cannot make a good kernel for this thing. So I'd rather just like look elsewhere in the architecture. Mingru layer is good. Default encoder. We're using this at the moment. And that's all the easy deletes, I believe, out of here. Yeah, that's the easy deletes. I don't know if it's easy to write a scripted opponent just that's also like reasonably fast. I don't think that is actually an easy thing to do. On the paid plan? Yes, but I don't think there is a paid plan anymore, SD. I think they just like copied all the current paid users to Legacy and kept supporting it. I don't even think I'm getting billed. And so I don't want to do it. Yeah. But like I don't understand, Jess, why do you need a scripted opponent? Can't you just like run your sweep and then at the end of each train just like run the last model versus Maya or whatever, anything you either have an API or local. You don't have to have your own scripted model, right? You can use somebody else's. Use that to estimate the elo and then just give that last point for the sweep. Does that work? I mean, if you want to speed it up, right, what you can also do is you can just use your other models, right? Like you can just take your model that's fast that you've evaluated against Maya or whatever. You assign it an elo based on your evals, and then you play against that for the evaluation. Like there are a whole bunch of things you can do to get out of this that don't involve you having to figure out how to make a good fast scripted model, right? We're kind of past that. Oh, this is so awful. We are for elo estimation. Let's point of sweep. Speed things up. We know Spencer and I doing things manually. So Jess, um, you have some trained models, right? You can go manually evaluate their elo versus some bots, and then you can assign them an elo score, right? Okay, so when you do a new run, and you want to assign an elo to the bot that you learned so that you can use that elo for the sweeps, you would just, after the training run, you just like add a thing that runs some games versus your other model of known elo, and then you can compute elo based on win rate against that. That gives you data for sweep and still fast. Yeah, exactly. Pretty much just that, Spencer. Lionheart. Yeah. Also, you can get close to 5,000 score on 2048 in like 36 seconds. So that's pretty cool. Get rid of this RMS norm kernel. This thing sucks. Yeah, this is not even correct, this kernel, right? manual stuff. All these ones. Launch view scan forward. We're just deleting old kernels right now. We're doing like the super easy dead code fixes. That's like the first chunk of cleanup. Sure, from undergrad, yep. I was out of laundry today. The heck is going on here? Oh, there's still so much jank that we need to clean up, isn't there? This will at least have us with a reasonable idea of how much actual code we have, right? PPO kernel. Holy. So these are just all old versions of kernels that we don't need anymore. So we just clean up this dead code and then we'll see how much we actually have left. FC max forward. Okay, this is the real kernel. The hell? Oh yeah, okay, we did some jank. FC relo FC max. Yep, this gets deleted. This thing is crap. Collects and values, RMS norm, fuse scan backward. Oops. Close some values. Our mass norm. I think I shouldn't clean this. These ones will be LLM cleaned up. This is LLM crap. The LLM will delete the crap that's no longer used. Let's just say that we have, what's this? Okay, we'll say we have an extra couple hundred lines worth of these, right? Okay, so we have, I want to say that this is mostly real code. It's like 5K lines, which is about what I expected. It's about 5K lines worth of stuff. Right, I have to delete old kernels. Actually, Claude can do this. When AGI, when I finish working on this, when I build it all. Take some time. Puffer is very fast now, though. Hey, Liberty, what are you doing today? Doing pretty well. I'm doing pretty well overall. I'm working on just cleaning up Puffer. I'm exhausted. I ran a 7:03 pace 5K just flat on the treadmill. I did some deadlifts for the first time in a few weeks. A couple other things. And I'm pretty tired, so I'm just going to go through and do the easy parts of the cleanup of Puffer today. You know, where there's really not much opportunity for me to screw stuff up. Just get like a couple thousand lines of stale code out of the repo. Just get all this stuff out. And then that gets us a good starting point for tomorrow. Because when I'm fresh tomorrow, I want to really start cleaning up the repo. When you're casting Fireball, I do recommend that article for anybody who has not seen the yeah, for anybody who has not seen the Fireball article. I mean, it was kind of a meme, but it's funny that it keeps getting more relevant year after year. It's on my articles tab, alongside the more serious stuff. Okay, I think we're allowed to use Claude to clean up Claude's own mess here, right? So all these shitty launch functions, these wrappers, just have it, like, go through and delete the ones that no longer exist. and then we'll be able to actually spend our time thinking about how to not have any of them at all. Once we have code that compiles because we no longer have bad wrappers. Let's see, what are we deleting? Log coef, fuse scan, loss forward. Yep. That's all fine. We get rid of this, we get rid of this, we get rid of this. Cool. When you firing laser. Do a barrel. You got some old memes there. So you must be late 20s or early 30s. Just based on the memes. Okay, thank you, Opus. Now go away. You start running again? Yeah, running's good. See, the annoying thing about all the running, right, is like you know it's good for you, but I have less energy for my actual weight training after I run. And yeah, it's good for you, but like you get home, you look in the mirror, and it's like, well, this does absolutely nothing for me on the outside. The cardio is good, but it's like, yeah, I'd be looking way better, and I'd be stronger, and I'd probably feel better overall that with that if I just spent more of my effort lifting. But you need the cardio, regardless. I was pretty happy with the 20-minute 3 mile on my birthday. That was a hell of a lot of effort. So that counts. Yeah, but the thing is that won't actually get you to do your exercise and be excited to go to the gym. Like I go for a very hard run, I'll just feel like awful afterwards. And go lift some heavy stuff and I feel pretty good. Really like to lift heavy rock. The hell? There we go. Ding a ding a ding. Don't worry about the speed. We're running other stuff in the background. That's why this is slow. It's splitting compute. All right, are we ready for the PR that like removes all the dead code? This is I mean this is the easy part of optimization, but it's still going to be very satisfying to see this. So we're going to have to work more for our lines deleted after this. $2.8K deleted. So that is about a third of the code in the library. About a third of the code for 4.0 we just deleted because it was just old dev crap. And now that's about, most of this is roughly real code. Let me use the restroom real quick, and we will think about what I can actually optimize today with remaining brain cells. All right. So let's see. I guess the way I want to do this is I want to kind of look at how much code everything is and think how much code I think there should be. No to slop. Brockman was always one of the guys I respected the most. Some of his latest AI stuff has been like questionable. Like for instance, writing shit in Rust because it's easier for AI to get it right is awful. Because Rust is just an absolutely shit language for people. 1100 lines of PufferLib, followed by 1,000 lines of modules and 1,000 lines of models. Blech. Okay. Main refactor questions. 16. Is that it? I mean, a hell of a lot of the code is just bloat from BF16 versus float 32, to be fair. Let me see how we're doing it now, actually. Let me see how we're doing it now. So just conditioned on D type. Launch mingrew gate. This is not a kernel launch though, this is a wrapper function. So wait. I'm confused then. Why can't I just call the templated one? I want to see if I can reduce. We've got very stupid branching at the moment. This is something I don't fully understand though, because this is C++ garbage. PufferLib. The torch code would be way better if I didn't have the branching. No, I don't like this. Wait, is it ATBF16? Oh, we are using BF6. Wait. No, we're not. It's stupid, right? Mingru gate inference kernel. All the other launch functions still use AT. Why do we need it this way? Launch. I have it right here, right? This like of T. Data pointer. It's templated. Why does Torch have their own stupid B float? think we can just delete this, no? Hmm. I'm thinking you just call the kernel, no? Let me just try something real quick. Let's just see if Claude's stupid. Because it very well could just be stupid. Is this the header thing again? Let me see if I can do this. This is valid, right? It's worth futzing with this to figure this out. Um, it can't possibly be this hard to be handling multiple D types, right? That's super annoying. I just love when we get no fucking error message on import. That's just amazing, man. Terrible language. Absolutely terrible language. I don't understand how this builds, but this doesn't import. Am I being an idiot? Yes, you're just being an idiot, dude. Maybe just don't be an idiot. Okay, undefined symbol. Okay. Hang on, this could still be viable. Call of war? No. I could also think if there's a non-template way to do this. Kind of a funny problem to be having, no? Let me go think about this a little bit. I'm gonna go get a refresh on my tea as well. I got an idea, chat. I got an idea on how to do this. You think we could leverage Puffer to get better weather models? Nothing, Bruno. We're getting 5 inches of snow. Doesn't DeepMind do that? I don't see how it's an RL problem. Let me try this myself. So what we do is like this, right? Launch main group gate inference. Remove this. Void. Let's see if this one works. You need to cast inside the lost launch function. Okay. Star next thing. No suitable conversion. Why is this the case? Wait, that's a weird, that is a weird conversion, isn't it? That's a weird cast. I mean, the thing is, this is all just like C++ being troll and shit. There's really no reason to have this. It's just like floats. It's just this, right? This also shouldn't need a cast. Should it? No, wait, it should. Too many arguments. To launch. Really? Combined. HB stream dtype. Void void const void int CUDA stream. Probably missing it in the H. Int dtype. No suitable conversion. Okay. Why can't we do it this way? Bfloat specific intrinsics. So screwy, man. Let me see if this actually works first. Let's just see if this works at all. Oops. Why does this not work? Can we not copy? We can copy. Templates are evil. They really are. This is so gross. I want to have something that works though first so we can like compare it to yeah, so we can compare it. Templates are compile level, right? Like it gets compiled the same as if I wrote it out explicitly, so it is fast. Like this is not overhead, right? I guess there is the from float function call, but if we inline it, it should be fine, right? Blah, 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 blah. Expected scalar. Type about found bfloat 16 type. Doesn't show the module one bit. It's very weird. Sub 5 second. Thank you. I don't know. It seemed like a good thing to post in a reply. PufferLib. Come on. Mingru gate, yeah? Oh, you absolute imbecile. You absolute imbecile. Mm. Okay. How about this? Yeah? It's the weird C++ thing. Tensor B, tensor base. Just use data pointer with no template. Gotcha. Weird ass C++ bullshit. If it doesn't exist, then why does this build? Huh, C++? Have you thought about that? Okay, it runs. Yay. We win. I'm just trying to figure out how we can simplify all this template crap. This macro is bad. You have to do a... Ugh. It's so gross. Mhm. This is annoying. Very, very annoying. So I mean, we're stuck then, right? It's either macro or or conditional, right? We try something. Let's just see. At least it wouldn't be in the torch code, right? And then it's just this. Oh, that's so much nicer, man. Look at this little tiny thing. By comparison. Not to be pushed if it works. Very nice. Very nice. This thing works too, doesn't it? That actually, if we can get that, that would at least be that would be C style. I do think it's worth spending time on this because I'm gonna say like a good quarter to third of the jank at the moment comes from our D-type handling. Need a runtime branch, yeah. Let me just stare at this for a few moments, guys. Does anybody have any ideas? I mean, we have this down now, so we need one macro globally, very light templating, and like these cast functions. State the problem. So I'm essentially trying to simplify the way that we handle multiple D types in our kernels, right? Because we need to support float 32, we need to support BF16. Ideally, it would be very nice if we could support more D types than that without having to add explicit branching. The problem is that I can only see two methods of doing this that are not explicit branching. One is that you have a macro. So you write your explicit branching once and then the macro applies it. I don't like this because it tends to produce really jank compile errors, but at least it's short and it's C native. The other thing is templating the kernels themselves. I have this here so that you can pass in float star or b float star to this, and I don't know if there's another way around this, essentially. I guess we could try to do what templates do with a macro. I don't know if that's a good idea. I think that the from float and to float can be macroed, right? Yeah, you end up writing your whole code in macros. Check on our experiments. We have some runs here. Look at this. They're not great, but we have them. Couple runs at least, yeah. This is where I think that the model is actually useful here. Like, I just spent a while going through this, thinking about this, and now this operation of applying this to all the kernels is, this is like a deterministic op, right? This is a pure refactor op. You know exactly the outcome. Claude workflow. The best Claude workflow is going to be when Claude is out of my workflow, frankly. I mean, this templating op is such a weird thing to have to do as well. It's like so uncommon that you get something that looks like this. Clippy. This is Clippy up here, except it's the puffer version. Hey, Peru. Oh, Perfect timing, actually. Do you have any better way of doing the B float and float handling than this? I spent a little bit of time on this, and this is the best thing that I could come up with. So we keep the inference, we keep these kernels pretty much exactly the way that they are now. Um, we we put one macro in the launch function here for the dispatch, and then the torch just calls this. So the torch doesn't have any macro or templating at all, and it's just passes as void star. Mingru. Yeah, so the problem is, well, if I do that, right, then I need to write, there has to be an if statement for every single kernel conditioned on the D type. And then even if I do that, like, I still don't get to delete the templating from the kernels themselves, right? So I'm stuck with it anyways. If there were a way to do all of this without templating, I'd be very, very happy. But other than literally copy pasting the entire kernel twice, I don't, and then putting a conditional, I don't think there is. Also, I think we have some speed issues with my version of the vectorization. I think you're right when you said like that there are some issues. Provide type of compilation. That's essentially what the templates do. Yeah. So I like, the thing is, I think you end up needing both because the problem with templates is that they're kind of cancer, right? Like you end up having to propagate the templates all the way up through your code. Holy crap. All right, let's see, what do we have here? Well, we get rid of all the nice, all these bad wrappers, so that's already a bunch of code deleted. I went through one of these carefully, and now I'm just having it like apply the exact same change to all the kernels because it's like a really dumb, simple deterministic op, right? I guess the alternative to the templates would be if we just decided screw it, we're supporting one D type, right? Sweeping once per env. That's weird. I think we need more profiles on the ends. I guess technically we could just decide that all the kernels are bfloat, or we could just decide that like every kernel is just one D type. No, we wouldn't do purely float 32 though. If anything, it would be purely bfloat 16. a 2B float one time. It's not a one-time cost. Then if you do it that way, so you like, if you pass, you essentially end up doing the exact same thing. That cast is a kernel call. So you end up wasting all that memory bandwidth. He's using int 8 and int 16. There is stuff with FP8 we could look into. The numerics are so sketchy with that. No clean solutions other than the templates. I guess what we'll do is we'll revisit this after we've used Puffer4 for a while, right? You know, because we can run some experiments. Hey, do we ever need FP32? Right? Like, is that ever a stability concern when you have nice fused kernels like this? And if the answer is no, maybe we just decide, you know what, we're just doing bfloat 16 for everything. libtorch YAML. Yeah. Okay, there, Claude, let's see what we have. This looks big and scary, but this should be basically free. This is an incredibly well-defined operation. This is just replacing casts with the equivalents. This is 1547 lines right now, right? Likes to delete literally all of my comments. Back to topic. Cheaper compute. Much slower than 3.0. Bottleneck on non-5090s. Which is similar to multiproc. Yeah, so Peru, I noticed this as well. I don't understand what's going on. I think I have a dated speed test, like there's nspeed.c, and then there's like a newer one that has other outdated tests around it and profile kernels. I think we need to pretty heavily profile everything and figure out what the heck is going on. Because it should be very fast. You said that you got a version of it that works without using OMP as well. Like, we can try that. I think I like the most helpful thing if you want to get involved with this. Of course, we need a version of this that actually lets you test stably. But the main thing would just be like, little benchmark, try the ends, see what the heck is going on. It should scale as expected. If it doesn't, we need to know why. If you have improvements, test before, test after, that sort of thing. Because there's definitely a Vec bottleneck, and there absolutely shouldn't be with the current design. Goes a bit different to balance LSTM based non-OMP. Well, I definitely want the multi-thread optimizations, Peru. And I think that there's going to be a spot in the future where we're going to want to drop torch entirely. And a lot of the ways that you've come up with for doing things are going to be very applicable. I mean, even the LSTM, I suppose, would be good. Like we might even want to just use the LSTM as a backend because we can't use BF16 with NVIDIA's nicely. Like they don't have a good BF16 backend from what I can tell. Okay, do this. Uh-oh, minus 400 lines of code. Cool. Let's see if it still runs. Presumably it forgot to modify modules, right? Yep. Oh, I'm being signaled for dinner. I'm gonna go get dinner. You got an insane breakout 5 second? Yes. Using sweep, it sweeps Peru. Um, I think we can go faster. I gotta get dinner, so I might stream a little later. I don't know. I'm definitely live all day tomorrow though, and I think the main thing is just gonna be cleaning up Puffer nicely for the release. So if that's interesting you can watch tomorrow. Anybody? And we are really, really close to 5,000 stars flat. This is rounding up. It's like 25 to go or something. So please star the Puffer on GitHub. It's free. It helps me out. Follow on X if you want more RL content, and join Discord to get involved. Thank you all.